Hi, good morning everyone. This is Sachin sir. We have seen lots of problems on degrees of freedom theories, on kinetic theories and thermal properties of matter. In today's class, we will see some problems on velocities. Okay. First of all, we are having average velocities or V bar. It is a root of 8 RT by pi m. And next we have RMS velocity, that is root of 3 RT by m, and most probable velocity, that is 2 RT by m. See, you have to remember this formula very accurately, because they ask most of the velocity related problem depending upon the temperature and mass relations. So temperature and mass relations, or depending upon pressure, volume, number of particles, mole relations. For example, PV is equal to mu RT. You have to in the place of RT here, you have to substitute to PV by mu, and all other things you have to know by just by referring the notes, or just by going through NCERT textbook. You will go through some of the problems which will help you in a long run. Okay, first of all, we have problem. A sample of gas is at 0 degree Celsius. 0 degree Celsius means a sample is at 273 Kelvin temperature. To what temperature it must be raised in order to double the RMS speed of the molecule? See, at this temperature they are saying RMS velocity is V1. Okay, if RMS velocity V2, that will be equal to 2 times this one, then temperature is how much they are asking. Okay, at temperature 273 Kelvin or 0 degree Celsius, RMS velocity is V1. Then to double this RMS velocity, that is V2 is equal to T1, what will be the temperature? Okay, for that you can remember the relation VRMS. V1 is you can see here, this will be directly proportional to root of T1. In the same way, divided by V2 will be root of temperature T2. If you take this roots to the left side, you will get we will get V1 square divided by V2 square is equal to T1 by T2. But what is V2? V2 is a 2V1, so this becomes V1 square divided by 4V1 square is equal to T1 by T2. V1 square get cancelled, so T2 is equal to T2 will be 4T1. T2 will be 4T1, that is T2 is equal to 4. T1 is 0 degree Celsius or 273 Kelvin. 273 Kelvin. So T2 will be around how much? Around 1092, I think. 1090, yes, 1092 Kelvin. 1092 Kelvin, but all the options are in degree Celsius. If 1092 Kelvin means how many degree Celsius? It has to be 819. Your option is option B. Okay, next CPMT UPCET AIMS question. At given temperature, RMS speed of the oxygen and hydrogen are in the ratio. See, oxygen, hydrogen, they are using in the praise just to refer RMS velocity variation with respect to mass of the molecule. Okay, for that I can consider RMS velocity of oxygen divided by RMS velocity of hydrogen as this, root of mh divided by mo. Sir, why we are getting like this? That only reason is mass is inversely proportional to RMS velocity. For this you have root of mh, mass of the hydrogen is 2, mass of the oxygen molecule is 32. Okay, atom is 16, molecule is 32. Okay, because we are having O2 and H2, so it will be 32. So this is 1 za 16 za, so VO by VH, VO by VH is equal to root of 1 by 16 is 1 by 4. So 1 is to 4 is the answer. 1 is to 4 is that is option D is the answer. Okay, just go through these formulas and solve both the problems. You will get the better understanding of the velocities. Okay, problems on velocities. Next, let us move on to next topic, that is values of densities of two diatomic gases. Diatomic gas means having only two particles, gases at constant temperature of pressure and pressure R, d1 and d2 are its densities. The ratio of the speed of the sound in these gases will be, see, velocity of the sound in a medium is given by correction into P, pressure, divided by density. Okay, remember this is Newton Laplace equation for velocity of light through any medium. This is Laplace correction. From this equation you can say that velocity of the sound in medium is inversely proportional to square root of the density. So formula V1 by V2 happens to be, this is d2 divided by d1. So option is which? Root of d2 by d1 is the option. Okay, see, you can also you can also explain directly this, because density has to be always inversely proportional to velocity. We can easily talk through air, but we cannot easily talk through wall, or through what, or through liquid, only because density is more there. So density is inversely proportional to velocity. Sound terminates easily. Okay, so boats and submarines and even whales, sharks, they are having horns. They produce bigger sounds so that it can penetrate through highly dense liquid surfaces. Okay, next question: at what temperature volume of an ideal gas at 0 degree Celsius becomes a triple? See, this can be solved by using equation PV is equal to mu RT. You have two conditions here: P1 V1 is equal to mu R T1, P2 V2 is equal to mu R T2. See, at least one has to be constant among PV and T. At least one has to be constant. At least P or V or temperature has to be constant. Even though 2 is varying, no problem, but one quantity has to be constant. Here, what temperature they are asking, that means temperature is changing. Volume is 0 degree Celsius becomes a triple, means volume is also changing. That means pressure is what? Pressure is constant here. P1 is equal to P2. So if I divide first equation by second equation, we will get V1 by V2 is equal to T1 by T2. P1 P2 gets cancelled because they are constant. At least one has to be constant. Both pressure, volume and temperature are changing, then pressure has to be constant. You will get equation V1 by V2 is equal to T1 by T2. So at what temperature volume is triple, they are asking. That means V2 has to be 3V1. That is, V1 divided by 3V1 is equal to T1 by T2. See, what temperature? T2 has to be calculated. T2 is equal to 3V1 by V1 into T1. So T2 is equal to V1. V1 gets cancelled. 3 into 0 degree Celsius he is asking. 0 degree Celsius in the sense what? 273 Kelvin, I think. Okay, 273 Kelvin. So T2 you can calculate and convert it into degree Celsius. You will get the answer. Okay, yes. Next, please convert it into Kelvin and degree Celsius. You will get the answer. Next, we move on to next concept. If the pressure and volume of certain quantity, if pressure and volume of certain quantity of ideal gas are held, then its temperature is. Okay. See, actually we have formula P1 V1 divided by T1 is equal to P2 V2 divided by T2. That means a temperature T2 we have to calculate now. T2 is equal to P2 V2 divided by P1 V1 into T1, but P2 V2 are getting hauled here. Okay, that means P2 is equal to V1, P2 is equal to P1 by 2, V2 is equal to V1 by 2. So you get T2 is equal to P1 V1 divided by 4 into P1 V1 into T1. That means P1 V1 gets cancelled. So T2 will be T2 equal to T1 by 4. That means it becomes 1/4. Becomes 1/4. Okay, so option will be option B. Okay, yes. Okay, thank you. Okay, we will solve some more problems in our next classes, and I will give some assignments over this so you can understand in a better way. Okay, but today's homework is calculate in average velocity, RMS velocity and most probable velocity. Arrange these values in increasing order. Okay, arrange average velocity, RMS velocity, most probable velocity in increasing order. If you want, you can refer through these formulas. Okay, increase them in write them in increasing order, arrange them in increasing order. Okay, thank you very much.